Makita po, ma'am.
Yes. Okay. Sige, go.
So, everyone. So, morning, everyone. We are the group 2, and we are going to discuss about the concentration and dilution of solutions. For of our report today, we will start with Miss Crystalline Plantig, followed by Sheena Ondar, next by Rachel Surya, then Ryan Pero, then Juliana Mulano. So let's get started. So Miss Crystalline Plantig.
So, concentration expression are often based on the number of moles of one or more components of a solution. The three most commonly used are molarity, mole fraction, and molality. So later may mga example po tayo ng molarity, mole fraction, and molality. The concentration of a solution is the amount of solute percent in the given quantity of solvent or solution. It is a ratio of the amount of solute to the amount of solvent. So there are several ways to express the amount of solute present in a solution. The concentration of a solution is a measure of the amount of solute that has been dissolved in a given amount of solvent or solution. A concentrated solution is one that has a relatively large amount of dissolved solute. So next is molarity. Molarity indicates the number of moles of solute per liter of solution and is one of the most common units used to measure the concentration of a solution. It can be used to calculate the volume of solvent or the amount of solute. The formula for molarity is equal to number of moles divided by to the liters of solution. So when we are calculate the molarity of a solution, the number of moles of solute must be divided by the total liters of solution produced. If the amount of solute is given in grams, we must first calculate the number of moles of solute using the solute's molar mass. Then calculate the molarity using the number of moles and total volume. So next is
Next is
Wait lang. Sheena? Sheena? Chappy. Sige, try daw ulit.
Narinig pa.
Nagputol-putol. Is it just me or sa inyo hasad? Or ako lang ang may problema sa internet?
Sa amin din po, ma'am.
Chappy pod. Chappy, Sheena. May ang net. Sige, try daw.
Narinig
Unmute ka daw. Unmute daw.
ko.
Walay.
Good morning, ma'am.
Sige daw, Sean. Chappy po ka, Sean. Walang maintindihan.
Dilution.
Sige daw.
Ma'am, okay na po.
Chappy.
Chappy.
Sige daw, pag-unmute daw, Sheena.
Narinig na po.
Sige daw, i-try daw. Walay. Ano daw muna? Sige daw, log out daw muna sa conference, tapos balik daw dito. Let's wait for them. Class.
Sige. Um, Dilution. Dilution refers to the process of adding additional solvent to a solution to decrease its concentration. This process keeps the amount of solute constant, but increases the total amount of solution, thereby decreasing its final concentration. Of solvent to prepare the desired concentration of a new diluted solution can be calculated mathematically. The relationship is follows. So, hindi makita yung ano yung
Okay.
For our formula, it is C1V1 is equal to C2V2, wherein C1 means the concentration of the original solution, the V1 is the volume of the original solution, the C2 is the concentration of the diluted solution, and the V2 is the final volume of the diluted solution. Next. For our first question, how much
Wala.
Wala mo.
Kalisord sa life.
Ako ma'am, audible ako ma'am.
Sige, go.
For our first problem ma'am, how much 0.5 MCl solution can be made by diluting 500 ml of 10 M8 hydrogen chloride? So sa given kay sa initial concentration, given ang C1 equals to 10 m HCl, for V1 equals to 500 ml. Sa C2 naman is 0.05 m na HCl. So ang missing niya is ang volume sa final concentration. Pag sa C1 V1 i-multiply ang 10 m at 500 ml. Tapos dito sa C2 V2 naman ang 0.5 lang, tapos pag i-multiply ang C1 at V1 maging 5,000. Tapos para ma-cancel ang molarity at mag-yield ng ml, i-divide. So ang maging kalabasan niya is 100,000 ml of therefore, there are 100,000 ml of 0.05 m of HCl solution can be made by diluting 500 ml of 10 m HCl.
Okay.
Next reporter, please.
Let's check for the problem number 1 if tama ang inyong gibuhat. Class, this is concentration and dilution ha. But for number 1, this is a dilution na problem. How will you know? Kasi sa dilution na problem, you will have Most likely either 2 concentrations and 2 volumes. Pero pwedeng missing ang isa, kaya nga hahanapin natin siya. Sa dilution class, it's a process of making a new solution from the stock solution or original solution, pero mas mababa ang kanyang concentration kasi magdadagdag tayo ng solvent. So in the case of problem number 1, how much 0.05 molar hydrochloric acid solution can be made by diluting 500 ml of 10 molar hydrochloric acid solution. So please make it a habit to list down the given so that it will be easier for you to identify what is missing or what is asked in the problem. So you have there C1 and V1. For C1, it's the concentration of our original solution. The V1 is the volume. Now, how do we identify this? Since this is a dilution problem, always class na yung ating first concentration is larger than the second one. So if you look at it, 10M versus 0.05, syempre the 10M is our stock or original solution because it has a higher na value. And then ang partner niya is ang volume, which is 500 ml. And then the C2 automatically will be the 0.05 molar. Now what is asked here is the volume. Kapag daw ang 10 molar, dinagdagan mo ng water or any solvent from 500 ml, magiging 0.05 molar ang kanyang concentration. Now, from 500 ml, so ilang, ano na yung volume niya ngayon? Ito yung formula natin ha, C1V1 equals C2V2. So this is not really a very hard one. All you need to do is to multiply this 10 molar times 500 equals 0.05 M hydrochloric acid times the V2. We are looking for this. Divide both sides with the 0.05 M para ma-isolate natin si V2. And then this one is 5,000. 5,000 divided by 0.5. Yes, this is correct. 100,000 ml. So, kapag si 10 molar na 500 ml, dinilute natin, ginawa nating 100,000 ml yung volume, nagdagdag tayo ng maraming example water, ang kanyang concentration ay magiging, syempre mas maliit, 0.05 molar. So yan yung ibig sabihin ng ating problem. And let me remind you, pag hindi inask sa problem na mag-convert kayo ng unit, do not convert. Because looking at the other na mga submissions, merong nag-answer ng liter. Now, if you look at the problem, hindi naman siya nag-ask na the volume should be in liter. So, stay with the ml. Kapag hindi nag-ask ha. But again, this is correct. Any question for number 1? Or clarifications? Wala. Sige, let us move on sa number 2.
Good morning, ma'am. I am audible po.
Yes, Rachel.
So, problem number 2. If I add water to 100 ml of a 0.10 mKOH solution until the final volume is 200 ml, what will the molarity of the diluted solution be? So, the molarity is being asked. So the given is C1 is equal to 0.10 M, V1 is equals to 100 ml, C2 is the missing, V2 is equals to 200 ml. To get the molarity, we are using the formula C1, V1 equals to C2, V2. So 0.10 M potassium hydroxide multiplied by 100 ml equals to C2 multiplied by 200 ml. So, cross out the ml, which is the 10M potassium hydroxide slash Mn over 200 ml equals to C2, 200 ml over 200 ml. Cross out the same unit, so equals to 0.05 M potassium hydroxide C2. Therefore, the molarity of the diluted solution will be 0.05 m potassium hydroxide.
Okay. Sige. So, this is problem number 2. If we are going to understand this, ang sabi dito, meron kang 100 ml na solution. Ang kanyang concentration ay 0.10 m. Now, kapag ka nagdagdag ka daw ng example, water here, most of the time we use water in diluting our solutions. Nag-dilute ka, nilagyan mo siya ng additional solvent and naging 200 ml na siya. Now, ang question is, ano na kaya ang concentration for this one sa new solution natin na naging 200 ml na? So, this is still C1V1 equals C2V2, but the one that is being asked here is the new concentration. Sa number 1, it's the volume. So, it's the same process. C1 is 0.10 times the V1, which is 100. That's 10 molar. This is not per ml, but times ml. Kasi nag-multiply man tayo dito. Okay, I missed that a while ago. But for this one on the other side, C2 times 200 ml, you cannot multiply this. So instead, let's divide both sides sa 200 ml to isolate the C2 because that is what we are looking for. And then cancel the ml here on the other side. You will be left with the unit molar kasi that's the unit for our concentration. So 10 divided by 200 is yes, 0.05. So again, the new solution will have a concentration of 0.05 molar. That is the process of dilution, class. You are going to add more solvent. So your volume will increase, but the concentration will always decrease for the process of dilution. Okay? Again, do not convert units if you are not asked to convert. Questions for number 2? Wala? Sige. So let us continue for number 3.
So problem number 3, I have 435 ml of a 1.5 m sodium chloride solution. If I boil the water until the volume of the solution is 350 ml, what will the molarity of the solution be? So the molarity is being asked. The given is C1 is equal to 1.5 m, V1 is equals to 435 ml, and C2 is missing. V2 is equals to 350 ml. To get the final concentration, we are using the formula C1, V1 is equal to C2, V2. So 1.5 m sodium chloride multiplied by 435 ml is equals to C2 and multiply with 350 ml. So 365.5 m sodium chloride slash ml on over 350 ml is equals to C2 multiplied by 350 ml over 350 ml. Since hindi natin ma-multiply ang C2 at saka 350 ml, so we put under both 350 ml. So it is equals to 1.864285714 m. Sodium chloride is equal to C2 or 1.86 m. Sodium chloride equals to C2. Therefore, the molarity of the solution will be 1.86 m.
Okay, wait lang. Actually, this problem is not really a dilution na problem. Again, this is not really a dilution na problem kasi diba the goal for dilution is we will add solvent to increase the volume but magbaba yung ating molarity. But as you can see, the process is the other way around. The given is you have 435 ml of the 1.5 molar sodium chloride solution. But hindi tayo nagdagdag ng solvent, instead binoil natin siya, and while boiling, remember if we are boiling a solution, the tendency is magiging gas siya after some time, mag-evaporate, and that will lead to the decrease in the volume. So from 435, naging 350 ml na ang volume. But it is asking also for the molarity. If nag-decrease yung volume niya, what now will be the molarity of the new solution? Though, ano siya kung ginatanaw kagaina, this is not really a dilution na problem, but we can still use the formula C1V1 equals C2V2. Again, we can still use the C1V1 equals C2V2 because you still have there the first concentration, which is 1.5, and then ang volume niya ay 435. Now, we are looking for the new concentration, but the new volume is given, and that is 350. Thus, this formula is still applicable. So 1.5 times 435 is 652.5. And yes, we will divide both sides with the 350 so that we can isolate the C2. So we have here 1.864285714 molar NaCl, or if I think I told you to have 2 decimal points here. So yes, this is correct, 1.86 molar NaCl. So as you can see, tumaas. Hindi siya talaga problem for dilution, but the other way around. This is the process of making a more concentrated solution. So binaba natin ang volume, so definitely the molarity will increase. But nevertheless, this is still correct, class. 1.86. Oo, na-accept ko na siya. Sige, questions for number 3? Anything? Any clarification? Wala? So let's have number 4.
Ito po, ma'am. Naririnig po ba, ma'am?
Okay, Shan, go.
Okay. Number 4, 12.5 grams of glucose, which is C6H12O6, is dissolved in enough water to make 550.0 ml of solution. The first question is, what is the molarity of the solution? So we have the given of 12.5 grams of glucose, 550.0 ml. So we are looking for the molarity. In order for us to find its molarity, so we should first look for the moles of glucose. So the formula for the moles of glucose is weight in grams, which is 12.5 grams of glucose over the molecular weight. So the molecular weight of the glucose is not given, so we are going to solve for its molecular weight. So C6H12O6. So the first thing to do is to the carbon has the subscript of 6, and it should be multiplied to its atomic weight. So 6 times 12 is equals to 72. So the next thing to do is to write the subscript of H, and it should be multiplied to its atomic weight, which is 1. So 12 times 1 is 12. Next is for the oxygen, which has 6, and multiplied to its atomic weight. 6 times 16 is 96. So we are going to add up all the answers. So 72 plus 12 plus 96 will equal to 180. So the molecular weight of the glucose is 180 grams per mole. So the next thing to do is we should find the moles of the glucose. So the formula is moles of glucose is equals to weight in grams over molecular weight. So 12.5 grams divided by 180 grams per mole is equal to 0.694444 moles. So the next thing to do is to find the molarity of the solution. So the formula is M is equal to number of moles over L of solution, the liters of solution. So the number of moles is 0.0694444 moles over 0.55 liters. So it will equal to 0.13 M.
Okay. Sige. So this problem is asking for the molarity of the solution, but this is not a dilution na problem ha. Kasi pag dilution na problem dyan, magbibigayan siya ng isang concentration and then the volume. But this time, nag-start tayo with dissolving our solute in our solvent. So, hahanapin natin yung kanyang concentration. So, glucose class is also our physiological sugar. Yan yung tinatawag natin na blood sugar. Okay? Diba, for diabetic people, they have increased blood sugar level. Now, this time, we can actually use this one to prepare for a glucose solution. In this problem, you have there 12.5 grams of glucose dissolved in 550 ml of solution. Our formula for molarity is always molarity, as you can see on the screen. Molarity is equal to number of moles divided by liters of solution. However, if you look at the problem, the moles is not given. The liters of solution, it is actually given, but it is in ml. So before you can proceed with the computation, you have to convert first 550 ml to liters. And how are you going to do that? Our conversion factor is 550 ml is sa isang liter meron tayong 1,000 ml. So sa baba ha, para ma-cancel. So 550 divided by 1,000 is 0.55. So yes, we have now the liters. Our problem is the number of moles. And for the number of moles class, our formula is the weight in grams of our solute divided by its molecular weight or molar mass, that's the same thing. And as you can see, the weight in grams is given, that's 12.5 grams. And ang gagawin lang natin is to compute for the molecular weight. Paano i-compute yung molecular weight? You list down all the elements in the compound. Like for glucose, you only have 3 elements there: carbon, hydrogen, and oxygen. And then identify how many atoms of each element are present. So you can see that in their subscripts. So for example, carbon, C6 means you have 6 atoms of carbon, and then you have 12 atoms of hydrogen, and lastly, you have 6 atoms of oxygen. Okay, 12 atoms of hydrogen and 6 atoms of oxygen. And then you will be multiplying each of them to their atomic masses, or we call it mass number or atomic weight. You can look at your periodic table for this, and my instruction was you need to round off the atomic weights to the nearest whole number. Thus for carbon, we have 12, so 12 times 6 is 72. For hydrogen, it's 1, so 12 times 1, it's 12. And 6 times 16 for oxygen, that is 96. And then to get the molar mass or the molecular weight, you just need to add everything. So that is correct, 180 grams per mole. So pwede nyo na siyang gamitin in the computation. So actually this way is correct. You just, kasi yung unit naman ng ating molar mass is grams per mole, pwede mo siyang baliktarin, mole sa taas, grams sa baba. So mahuhulog pa rin siyang weight divided by molecular weight. But nevertheless, you can cancel the grams. You will be left with the moles. So 12.5 divided by 180 is 0.06944444 moles of glucose. So kung nakuha mo na ito, we can proceed with the molarity. Please, sa computation, you round off sa final answer na. Please do not round off during the process so that our final answers will be more exact or more accurate. So 0.06944444 divided by 0.55 is 0.126262627 molar. But you can also, you have to round this off to 2 decimal places. So yes, this is correct. 0.13. You can have 0.13 moles per liter. You can answer like this kasi it's moles per liter naman. But moles per liter is equivalent to capital letter M. So either of the two class, correct yan sila. Okay? Questions for number 4? Any clarification so far? Wala. Nagkasinabutaan ni atong molarity. This is how you do the computation for molarity, ha? Sige, let us proceed sa number 5.
Number 4B pa po.
Ay, may B pala ito. Sorry. Sige, go.
How many moles of glucose are contained in 237 ml of the above glucose solution? So we have the given of 237 ml, and if we convert it to liters, it will become 0.237 liters. So we have the 0.13 m. So we are looking for the moles of the glucose. So we have the original formula of M equals number of moles over L of solution. So we will going to derive the formula. So we will have the number of moles of solute is equal to the molarity times L of solution. So 0.13 moles over L multiplied to 0.237 liters is equal to 0.03081 moles or equal to 0.03 moles. Therefore, 0.03 moles of glucose contained in 237 ml of the above glucose solution.
Okay. Sige, karugtong ito ng first problem ha. So this is 4B. Definitely we will be using your answer sa letter A to get the answer for this letter B. Okay, now what is asked here is the number of moles of the glucose of the above solution, and then the given is 237 ml. So remember our original formula, sinabi ni Sean kanina, molarity is equal to moles of solute divided by liters of solution. We have computed already for the number of for the molarity. We are looking for this one. And then this one is given, but you need to convert first. So in converting 237 ml, i-multiply natin. Isang litro, meron tayong 1,000 ml. So this is 0.237 liters. So this is correct. We can derive actually the formula class like this one. I-multiply kasi natin yan siya to get the moles, right? So your formula will become moles is equal to molarity times liter. So this is actually correct. Na-derive ito siya na formula coming from here. Now, the molarity is computed sa letter A, that's 0.13 molar, or that is equivalent to 0.13 moles per liter. Kaya, nilagay nila dito, moles per liter. Kasi mahirapan tayo mag-cancel kung capital letter M ang gagamitin natin. Now, cancel the L, multiply 0.237 times 0.13 is 0.03081 moles, or kung 2 decimal places, 0.03. So yes, this one is also correct. Yeah, 0.03. Questions for letter B? Any question? Wala. I hope naintindihan yun ha. Dinerive natin ang formula because we are looking for the number of moles. the molarity is already computed kasi sabi niya above glucose solution. So that's letter A. Wala. So let's move on sa letter C.
So for the letter C, what volume L of the glucose solution would contain 0.079 moles of glucose? So we have the given of 0.079 moles of glucose, the 0.13 m. So again, we will going to derive the original formula. So it will become liters of solution is equal to the number of moles of solute over molarity. So it will become 0.079 moles over 0.13 moles per liter. So the answer will be 0.607692307 L or equal to 0.61 liters.
Ayan. Sige, liters of solution. Baliktad naman ang hinahanap dito. The same formula, moles over liter. Wait, let me write it. M is equal to moles per liter. And then above solution pa rin. So the same thing, 0.13 m pa rin dito. This time, the number of moles is given. So 0.79 moles. And then sa baba ang liters, we are looking for this one. So if we derive the formula, M is equal to moles per liter, di ba? Iko-cross multiply natin yan. This will become, ibaba natin si moles equals M times liter. But then we are looking for the liters. So let's divide both sides with the letter M. So makancel yan. Pag derive natin, class, this is now our formula. Liter is equal to moles divided by the molarity. Kaya kung titingnan nyo yung sinulat nila dito, you have there sa taas the given 0.079 moles and sa baba divided by the molarity. Okay, sorry, the molarity. This is actually the molarity. Ano lang nila, instead of using the capital letter M, we'll use the moles per liter so that we can cancel the unit. So you can cancel the moles, you will be left with a liter. So 0.079 divided by 0.13. To decimal places, yes, this is correct, 0.61 liters. Kapag meron kang 0.079 moles ng glucose, ang kanyang volume is 0.61, automatic ang kanyang concentration ay 0.13 molar. So, ayan, pinakita ko sa screen how to derive the formula, ha? Questions for this letter C? Before ta mag-move on sa number 5. Wala. So, sige, let's have the number 5 reporters.
May audible po, ma'am.
Okay, oo, Ryan. Sige, go.
Problem number 5. What is the molarity when 25 grams of the compound sodium chloride with a molar mass of 58.44 grams per mole is placed in 85 ml of the total solution? So the first thing we're going to do here is, again, find the given of the problem, which are the molar mass and the volume. And in solving for the molarity, the first step we're going to do is to first find the mole of the compound by using the formula weight in grams over molar mass. So we're just going to substitute the given, which will give us the equation of 25 grams sodium chloride times 1 mole of sodium chloride over 58.44 grams of sodium chloride, which will give us the result of 0.42789,185 mole of NaCl. And in solving the molarity, we're just going to use the formula of the molarity, which is number of moles over liter of solution. And again, we're just going to substitute the respective given to the formula, which will give us 0.427789,185 mole of NaCl over 0.085 liters. And by the way, we converted the 85 ml to liters, which give us the result of 0.085 liters. And then we're just going to do the math here, which will give us the result of 5.032813947 moles per liter or molar mass of NaCl. Or if you're going to convert I mean in two decimal places, which will give us, okay na po, ma'am.
5.03 molar. Okay.
I'm molar pa.
Molar. We call it molar. The expression of concentration is called molarity, but pag unit siya, capital letter M, ang tawagan na sa iya kay molar. Okay, kinsay nagamit diri og 58 lang. Basig na nagamit og 58 lang. I mean for
Opo.
the molar mass. Okay, it's okay. It's okay if you have used the 58 grams per mole, since my instruction was to round off the atomic weights and the molar mass to the nearest whole number. It's okay na nagamit kayo ng 58. Pero kung ginamit nyo din naman itong 58.44, which is already given in the problem, okay lang din. I have no problem with that. Medyo mag-iba lang yung answer natin, pero 5.03 or 5.07, I think, kung 58 lang ang ginamit nyo is considered. So in this case, hindi na nag-round off. It's okay kasi it's already given. So hindi na tayo kailangan mag-compute for the molar mass of NaCl. Diretso ka na sa number of moles. So 25 divided by 58.44. Yes, that is correct. 0.427789,185. Tapos, kung meron na yan, pwede ka na mag-proceed with the computation of the molarity, number of moles divided by the liters of solution. But the liters of the solution is given in ml, so i-convert lang sa nimo siya. Always remember, our conversion unit sa isang liter, meron tayong 1,000 ml. So kaya naging 0.085 liter siya. So divided by 0.85 liters, yes, the answer is 5.03 molar of NaCl. So, di ba itong NaCl is stable salt? Pag nakakay 25 grams, i-dissolve mo siya sa 85 ml na tubig, plus ang iyahang concentration is 5.03 molar. But if you use the 58, so this will become 25 divided by 58 grams per mole, you will have 0.43. 103482 divided by 0.085. 5.07 molar is also considered. So I have no problem with that. Questions for number 5? Anyone na may clarification for number 5? Wala. Let us proceed sa number 6.
So for problem number 6, 4 moles of lithium chloride is dissolved in 5 liters of water. What is the molarity of the solution? So again, the first thing we're going to do is to find the given, which are the number of moles and the volume. So by using again the formula for molarity, which is the number of moles over solution, we're just going to substitute the given here, which will give us the equation of 4.4 moles of lithium chloride over 5 liters of the solution, which will give us the result of 0.8 molar lithium chloride. Therefore, the molarity of the solution is 0.8 molar lithium chloride.
Okay, this one is a much easier na problem kasi the moles is already given, the liters is already given. All you need to do is to divide this to get the molarity. So 4 divided by 5 is 0.8. Wala na kay daghang himuon ni class. Automatic na. Okay? Pag gihatag na ang moles, tapos ang volume sa solution kay diretso na liters, divide ka na agad. So this is correct, 0.8 molar. Questions? Wala? Mag-compute lang tag moles ha kapag ka grams ang gihatag din ha. Pero kung moles na diretso ka na din with the computation of molarity. Okay, let's have the last one before tayo I think 8 problems ito, no? Hindi pala last one. Problem number 7.
Hello.
Sheena. Choppy gyapon ka, Sheena.
Shopee pa rin po, ma'am.
Sige, dili na. Go.
Okay po, thank you po. So the problem number 7 is 100.0 ml of 2.500 molar KBr solution is on hand. You need 0.5500 molar. So what is the final volume of solution which results? So our given here is C1 is equal to 2.500 molar KBr. Our volume 1 is equals to 100.0 ml. C2 is equals to 0.5500 molar KBr. Our final volume is unknown. So, hinanap pa natin siya. So, our given sa dilution, C1, V1 equals to C2, V2. So, gi-substitute namin yung given doon sa given formula which is 2.500 molar KBr multiply 100.0 ml equals to 0.5500. So we divide both sides 0.5500. Sorry po, ma'am. We divide both sides 0.5500 molar KBr. So, dito sa kabila, ang naka-cancel out dito is yung 0.5500 molar KBr at yung sa kabila naman po, na-cancel out yung unit. So, ang naiwan po is 2.500 multiply sa 100.0 ml over 0.5500 equals to V2. So, we multiply yung 2.500 sa 100.0 ml. Answer po niyan is 250 ml over 0.5500 equals to V2. So, gi-divide po namin siya. So, ang answer po is 454.545455 ml equals to V2 or 454.55 ml equals to V2. So, therefore, the final volume of the solution is 454.55 ml.
Okay, very good. This is another dilution na problem ha. So, unsay ginapangita, it's the volume, the final volume of the solution. Ang original solution, you have there 100 ml, ang kanyang concentration is 2.5, so mo na siya ang C1 and ang V1. Now, ang kailangan daw for the new solution, dapat iyahang concentration is 0.55. So, unsa kadaghan nga volume imong kailangan? So, 2.5 times 100 divided by 0.55 to isolate the V2. So, this is correct for 154.55. So, i-dilute natin class from 100 ml, dagdagan natin ng solvent, maging 454.55 ml yung volume niya, ang concentration from 2.5 bababa siya into 0.55. That's the process of dilution. Okay, last one before tayo mag-end.
For number 8, how many grams of beryllium chloride are needed to make 125 ml of a 0.050 molar solution? Before siya mahanap is kailangan muna natin hanapin ang moles of solute gamit ang molarity na formula. Ang ang molar mass is 79 grams per mole. So, gi-derive ang molarity na formula para mahanap ang moles of solute. Ang kalabasan niya is i-multiply na lang ang molarity at liters of solution. So 0.050 molar times 0.125 liters galing sa 125 ml solution. Ang answer is 0.00 625 moles. So, kay meron na tayong moles, pwede na natin isolve ang grams of solute or weight, grams of solute gamit ang moles na formula. So, derive na naman ang formula. Ang i-multiply is 0.0625 moles times 79 grams per mole. Kaya meron mang mole parang i-cross out yung moles and maiwan na lang yung grams na unit. So ang kalabasan is 0.49375 grams of beryllium chloride or 0.49 grams as sa 2 decimal places.
Okay.
Therefore,
Sige, go. Sorry.
Therefore, to make 125 ml of a 0.050 molar solution, it needs 0.49 grams of beryllium chloride.
Okay, very good. This is actually kabaliktaran nga problem. No, most of our problems from problem number, unsang number to, given ang grams, tapos ang ginagawa natin will look for the moles, tapos hahanapin natin si molarity. Ito yung ating process sa mga nauna na problem. But this time, given si molarity, ang ihahanapin natin si gram. So baliktad. From molarity class, we will look for the number of moles before natin mahanap si grams. So yung molarity dito is 0.05. Remember, molarity is equal to moles per liter. Given si molarity dyan, hahanapin natin si moles. Si liters naman is also given. It's 125 ml. Convert mo lang. This is 0.125 liters. So, imumultiply mo yan siya dyan, class. 0.05 moles per liter equals moles. Sa baba si liter, class, that's 0.25 liters. Cross-multiply mo, makakancel si liters, mahahanap mo si moles. Actually, ito yung derived formula niya. Number of moles will be equal to molarity times liter of solution. This is moles per liter here. Makancel ang liter. This is the number of moles. Tapos babaliktad. Pag may moles ka na, hahanapin natin yung grams. Gamit yung isang formula natin, which is moles is equal to weight in grams divided by the molecular weight. Kung magde-derive ka na naman ng formula, cross-multiply ka na naman, this will be weight in grams equals moles. So this is the moles here. And then this one is the molecular weight. So hindi lang napakita, but yes, molecular weight is 79 grams. You have beryllium chloride there. So this is Be1. Ang chlorine is 2 times 35. This is 70. This is 9 here. So all in all, that's 79 grams per mole. Okay? So i-multiply mo lang yan siya dyan, class. 79 times 0.00625 is 0.49375 grams, or kung 2 decimal places, yes, 0.49 grams. That's how you solve for this kind of problem. Pabaliktad siya. Okay? Questions for number 8. This is the last one, right, reporters?
Yes po.
Okay.
Yes,
Questions. Before ta mag-end, it's 10:29. Sigma late na mo kay Ma'am Charm. Ang grades. Can you PM me na lang for the grades? I cannot access the grades. Your grade should be coming from Perlado. So kindly ask her. Let me